the biggest thing or biggest question now we should have in our mind is how we identify the devices. How we can identify the devices means address. So we are going to discuss about address first, both address, MAC address and IP address, right? After IP address, we will start the subnetting. Our topic will be subnetting. Then we will move to OSI model. In OSI model, we are going to understand two most important topic, that is TCP header and IP header. Okay, that is part of CCNP. And before TCP header and IP header, we are going to discuss very basic things, very basic about IP address. So guys, if anyone is thinking that I don't need to learn, I don't need to, revise IPv4 again or the basic OSI model, so you can directly join after 2 to 3 days. Okay, but if you are thinking that no, I want to learn everything from the zero level, so you can be here. Okay, now let's begin. Topic is types of address or types of addresses. We have two types of address. First one is physical address, or we can say MAC address, or what we can say to MAC address,
Media access control.
media access control, anything. Okay, this is nothing but your MAC address. And second type of address is your IP address. Okay, first we will discuss about MAC address, then we will start IP address. Okay, so topic now is MAC address. We discussed that there are two types of address through which we can identify devices over network. First one is physical address, that is MAC address, and second one is IP address. We are going to discuss first MAC address. MAC address. Now guys, MAC address is an 32 bits address. 48 bits address. It is an 48 bits address, and we represent MAC address in which representation, guys?
Hexadecimal.
Yes, we represent it in hexadecimal. To represent one hexadecimal character, how many bits is required? To represent one
Four.
hexadecimal character,
4
4
bits.
bit is required. Very good. That means how many total character we have in MAC address? It is an 48 bits address, and you are saying that to represent
Well,
one hexadecimal number we need 4 bits. So total number of character in the MAC address will be 12. Yes, 12 character will be there. Now 12 character can be, value can be 0 to F. As you know, in hexadecimal we have total 16 character. Sorry, 15, 16 correct character. 0 to F. Done. So character can be 0 to F. So my lowest MAC address can be what? 12 times 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is my lowest MAC address, and my largest MAC address can be all F. 4, 5, 6, 7, 8, 9, 10, 11, 12. All MAC address will lie between this range. Okay. So let me write one MAC address over here. 1, 2, 3, 4. 4 character, 5, 6, 7, 8, 9, 10, 11. This is a MAC address. Size of this address is 48 bits. There are 12 characters, 3, 3, 4, 4 and 4. Now we have representation. See, Control plus C. Either we can represent this MAC address like this, or I can represent this MAC address like this. How many character we have over here? 2, 4, 6, 8, 10, 11, and let's say in the last it's 1. We can represent this MAC address like this. This is one MAC address, or I can represent same MAC address like this also. Like this. There is no any difference between this MAC address and this MAC address. In both MAC address there are 12 character. This is how Windows operating system represent MAC address, and this is how Cisco represent their MAC address. If I will show you the MAC address of Windows operating system, CMD, IP config. See the MAC address representation. IP config all. See, are you able to see, guys? Here is MAC address.
Yes.
After 2 character they are using what? One hyphen sign. But if I will show you the MAC address of Cisco devices, let's say here I am going to show you the MAC address of R1. Any interface of any interface, let's say interface 0/0. Enable show interface F 0/0 include bus. See, this is MAC address of Cisco. So this is how Cisco represent MAC address. I am guys getting echo. Who have joined through multiple mobile? Hello. Now it's fine. So please mute yourself if anyone is using multiple device. So see Cisco, how Cisco represent MAC address. So in Cisco representation there are 3 fields. Each field carry 4 character, and as you know all are hexadecimal characters, so each carry 4 bits. Done. Now see how we design MAC address. So in this MAC address, hello. Okay. In this MAC address there are 2 parts. We have divide this MAC address into 2 parts. This one is first 24 bits and this one is last 24 bits. We said that first 24 bit will be always provided by the Internet Authority, that is INA. That first 24 bits will be always OUI, Organizational Unique Identifier, that will identify the organization. And the last 24 bit will be the vendor assign. That will be assigned by vendor company. That will be decided by vendor company. Okay. So let's say any company want to design some computer. Let's say they are new company. So they have just purchased one OUI from the INA, and his OUI is 00001:12. Okay, so this is the OUI of a company, of which company? Of let's say XYZ company. Done. This is network of let's say XYZ company. Okay. After that, this company need to manufacture the MAC address. So this company have how many bits? 24 bits. That means it can design how many MAC addresses? 2 to the power 16 MAC address
24.
through single OUI. 24. We divide MAC address into 24 by 24 bits and 24 bits. First 24 bits is organizational unique identifier, and last 24 bits is vendor assign. Now there is one organization XYZ who is manufacturing the computer, so they need MAC address for their NIC card. So they have just purchased one OUI from INA, and his OUI is OUI is this one. This is wrong. I think there is one more zero. This is, let's say 0000 colon 01. This is OUI of XYZ company. So XYZ company need to manufacture the multiple MAC addresses. So OUI will be the same and it will provide last 24 bits. So let's say last 24 bits is 00 colon 0001. After that, in the second MAC address, OUI will be the same and 00 colon 0001. This will be the second MAC address. In both MAC address, guys, see OUI is same. So after 2 to the power 24 computer, after 2 to the power 24 NIC card, this company XYZ need to purchase one more OUI. Right? And let's say this is OUI 24 and this one is, let's say, vendor assigned 24. In the same way, there is one more company.
10, right?
Sorry, it will be also. This is 02, not 1, 2. Thank you, brother. Okay. In the same way, let's say there is one more organization, ABC, who is also manufacturing the computer. Say they need also one OUI. So it will purchase OUI from the INA. And let's say his OUI is 000 colon 02. Okay. Done. Now, vendor assigned part will be also here also what? 00 colon 001. Here also 00 colon 0002. Yes. So see, OUI part of same vendor is in same vendor company. OUI is same, and in between vendor company, what is different? What is same? It can be same or it can be different. Vendor assigned bits. So if vendor assigned bits is also same, then also MAC address is unique because both are using what? OUI. Done, guys?
Yes, sir.
We have divided MAC address 48 bits address into two parts. First is OUI and second one is vendor assigned. First 24 will be provided by organization and last 24 bit will be provided by the vendor company. Maybe vendor assigned field can be same of two different organization, but MAC address will be always different because both are using unique OUI. Done. Now let's talk about the IPv4 address. IPv4, or we can say directly IP address. Now IP address is 32 bits address. It is an 32 bits address represented in dotted decimal. And we have 4 field over here, and here representation like field, these are predefined in IPv4. Okay, so representation of IPv4 will be same on all vendors. Not like MAC address, that MAC address representation in Windows operating system is different and MAC address representation in Cisco IS is different. IP address of all vendor representation will be same. There will be total, there are four fields. So if we have 132 bits address and we divide that address into 4 equal part, so each part will carry how many bits?
8.
Each field will carry 8 bits.
8 bits.
8 bits. Definitely yes. By using 8 bits, what maximum value you can represent?
255.
Yes. Minimum value will be 0, 0, 0, 8 bit. If 8 bit is 0, then definitely you will get minimum value. And if all bits is 1, then you will get maximum value. Yes or no? If
Yes.
all bits is 0, then what value you will get? 0. If all bit is 1, then what value you will get?
1.
255.
255.
Exactly. That means in each octet value can be vary from 0 to 255 only. Yes or no? And in IPv6 we represent we separate each field with dot. We separate each field with dot. So let's say I have one IP address of this one, 4 times 4 bits, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, let's say this is my complete IP address in binary. So we have how many field?
4.
4 field. Like this. Like this. So what I am saying that we separate each field with dot. We separate each field with dot. That means here we have separated with 1 dot. Here also we have separated 8 bits with 1 dot. And here also we have separated 8 bits with 1 dot. And this X can be what? This
0 or
X
1.
can be 0 and 1. Definitely yes. Okay. So my lowest IP address will be 0.0.0 and my largest IP address will be 255.255.255.255. Yes or no? Means all IP address will vary from here to here only. Now we divide IP address into some classes. Class A, class B, and class C. We divide IP address on the basis of value. We divide IP address on the basis of value present in first octet only. The value present in first octet, because we have reserved 1 bits for class A, 2 bits for class B, 3 bits for class C. Okay, first of all understand the range, then I will make you understand that also. Range of class A is, in first octet value will be 0 to 127. In class B range is 128 to 191. In class C range is 192 to 223. We have 4 class D and class E. Guys, as a network engineer, we will work on these 3 classes. Class D is used for multicasting. You will see the range of IP address in OSPF or EIGRP, in the dynamic routing protocols which are using multicast address are reserved IP address from class D. But now let's discuss about these three classes. So here what I am saying, if value in first octet will be from 0 to 127, that means that IP address is class A IP address. If IP address is from this range, that means IP address is belongs to class B. If first octet value is from this range, then IP address belongs to class C. After that, we have defined the subnet mask, because each IP address is actually combination of two things: network bits plus host bit. In all IP address, there should be some network bits and there will be some host bit. Maybe there are all network bit, or maybe there are all host bit. So that can be also scenario. But here what I am saying, generally an IP address is combination of two things. That the first one is network bits and second one is host bit. And subnet mask is the tool which specify how many network bits are there and how many host bits are there in an IP address. And subnet mask is also predefined for all classes. That is, we are saying default subnet mask as well. Okay, till here any doubt, guys, to anybody? Yes, till here if anyone have any doubt? No, guys,
No, sir.
all clear? Okay,
Yes, sir.
so we have defined subnet mask as well for all classes. So see, subnet mask for class A is 255.0.0.0. 255 means in first octet you can represent subnet mask also in bits. Subnet mask is also binary value which is represented in decimal. Okay, so here in first field all bit is what? 1. That means in class A first 8 bits are network bits. As subnet mask is saying what? All 1 means network bits and 0 means host bit. And it is saying that last 24 bits is host bits. If you will convert it, this subnet mask, into binary, then binary will be this one. See, dot 8 times 0, again 8 times 0, done. This will be the one more field is there, that is all 0, 4, 5, 6, 7, 8, 9, right? This is subnet mask in binary, this subnet mask. So actually this subnet mask, see here, first 8 bits is what? 1, and 1 means network bits. That means for class A, how many network bits are there? 8 bits. And how many host bits are there? 24 bits. Okay, this is predefined for class A, that whenever we will use any IP address from class A, subnet mask, default subnet mask will be this. There will be 8 network portion and 24 host portion. Okay, for class B subnet mask is 255.255.0.0. It means in binary it will be 1 1 1 4 5 6 7 8. Like this. So in class B we have 16 network bits and 16 host bit. In the same way for class C also we have reserved subnet mask, that is 255.255.255.0. Here we have 24 network bits and 8 host bit. Yes guys, is it clear? Is there anything in chat? Yes, Bisnu.
Sir, class A IP is 0 to 126, right?
127.
But 127 IP is reserved for loopback.
So it is loopback is reserved from class A, brother.
Okay,
This
sir.
is an
Okay.
interview question. Interviewer can ask you this question also, that loopback
Okay.
belongs to which class? So it belongs to
Oh,
class A.
oh, okay, sir. Thank you,
Okay.
sir.
From the
Yes.
same class, there are lots of IP address reserved for other purpose as well. Like in class A, we have private IP address, public IP address. Yes or no?
Yes, sir.
So there are some IP address reserved for private range. There are some for public.
Public range IP address. Yeah.
Okay. So by
Yes.
default, for class A, we have 8 network
250.
bits.
Yes.
255.0.0.0. For class B, 255.255.0.0.0. And for class C, 255.255.255.0. Now question is how we divide this IP address in this range. See, for this range, what we did, we reserve one bit, first bit, that will be always 0 for class A. So for class A, we have 8 network bits. Out of 8 network bits, if we have reserved 1 bits, then how many bits are left?
7.
7. So if all 7 bits is 0, then what value you will get?
0.
Then you will get 0. And if all bits is 1, all rest bit, then what value you will get?
255.
No,
55.
255.
127.
127. Right.
127. So that's why this is a range. For class A, actually we have reserve 1 bits. Means from class A, guys, how many network we can design? 2 to the power 8 or 2 to the power 7?
2 to the power 7.
2 to the power 7. And this is one interview question. Oh, sorry, I'm saying interview question. CCNA 200301 exam paper question. That question was like this. From class A, how many network we can design? How many network we can design? And option is 2 power 8. Option B is 2 power 7. Option C is 2 power 16. And option D is 2 power 24. So right answer is 2 power 7. Right, not 2 power 8. In the same way, for class B, we have reserved 2 bit. That first bit will be always 1 and second bit will be always 0. So now for class B, how many bits we have free?
2 to the power 6.
6 bits are free. So if all 6 is 0,
Can you please go over that again? Because I don't understand the calculation of that bits and the 2 power 7, whatever.
you know binary to decimal? You know, brother, binary to decimal?
Yeah, I want to understand that too as well.
You know, this is decimal. This is decimal value of these 0, 1, 1, 1, 1, 1, 2, 127. And this is here, from this side decimal value is 0. Again, I am saying for class B, we have reserved 2 bit. See, this is nothing but your 128. If you will convert, if you will learn a binary to decimal, so this value is your 128, this value is your 64, this is your 32, this one is 16, this one is 8, this one is 4, this one is 2, and this one is 1, like this. Okay, so if you don't understand, don't worry, you understand the range of IP address from class A 120 to 127, from class B 128 to 191. This is clear now to you? Only this is important.
Okay.
This is not important. Okay. From class A, only always keep in mind that from class A we can design only 2 to the power 7 network. 2 to the power 7 network. Okay. This is exam question. Maybe anyone can ask you this question, okay? And maybe I will ask you in future. So and keep in mind this only, that for class A we can design 2 to the power 7 network only, because 1 bits is reserved. Done? Done, brother?
Yes,
Yes,
sir.
sir.
Okay. Now if all bits is 1,
So one second. Now,
yes,
if like, let's assume the 0 is there, that's 2 to the power of 8, right?
yes, you
So
tell
we
me
take
what will be
1
the
to
decimal value of this binary. Let me write over here 1 0 and 1 1 8. What is the decimal value of this binary? If you will know the binary decimal value of this binary, na, you will get the range. Because here what value I will get, guys? Can anyone tell me? This is 128. So I will get 128 over here. And from this side I will get what value? 191. In the same way for class C we have reserved 3 bit 110. Now we have how many free bits? 5 only. So if 5 bits is 0, then we will get value what? 192. If all value is 1, then I will get 2, 4, 6. If all value is 1, then I will get value 2, 2, 3. You guys can calculate. And this is how range is there of each classes. Okay. So if this is confusing for you, leave it. Just keep in mind the range. If I am writing one IP address over here, 10.10.10.10. So this IP address belongs to which class?
class A.
Class A. Because to identify the classes, we are not going to check this value. Just I am going to check the first octet value only. The value present in first octet. If the value in first octet is from range 0 to 127, that means this IP address belongs to class A. Okay. Yes. Who was asking question? You can speak now, brother.
Yeah, I thought that was what I was asking. I think I'm okay. I tend to understand that now.
Okay.
Thank you, sir.
Now I am writing one more IP address over here, 172.16.0.0. This IP address belongs to which class?
Class B.
Class B.
Class B,
Class B. Because here first octet value is 172,
172. Yeah.
and whenever value will be this range, then that IP address belongs to class B. If I am writing one IP 192.168.10.10, this IP address belongs to which class?
Class C,
Class C. Because this value is 192 and
192.
here range is 192 to 23 for class C. Done.
Does it mean that for class B we can design up to 2 to the power 6 network?
2 to the power y6. See, I am
Because-
asking you now some question. See, from class A we can design how many network? 2 to the power 7. Okay, for class B, I am giving you option 2 to the power 16, 2 to the power 14, 2 to the power let's say 24, and 2 to the power 8. Which one is right answer? For class B, how many network we can
2 to the
design?
power 14.
2 to the power 14. This option is right. For class C, 2 to the power 21, 2 to the power 22, 2 to the power 23, and 2 to the power 16.
2 to the power 21.
21, sir. 21.
2 to the power 21. Because for class A, we have 24 network bits. Out of that 24 network bits, we have reserved 3 bits. First bit will be always 1, second bit will be always 1, and third bit will be always 0, like that. Okay.
So these bit is used to represent the class
Sir, not understood, sir.
IP address.
Yes, Rohit.
Sir, for
Yes.
class B, why it is 2 to the 14?
Because total network bits for class B is 255.255.0.0 means 16 bits. Out of 16 bits, you have reserved 2 bits.
Got it. Thank you.
Anything else? Am I right, Nirav? Okay. Right, Vishnu? Am I right? Yes, Vishnu.
Yes, sir. Understood.
Understood.
Yes.
Sunita, got it?
Yes, sir, got it.
Gunjan?
Yes, sir. Yes.
Okay, done. Let's move further. Now I am writing one IP address over here. That is 192.168. Or let's say 10.10.10.10. Subnet mask is 255.255.255.0. This is subnet mask. Okay. So first thing is this IP address belongs to which class?
Class A.
Class A, sir.
Okay. So this one is actually IP address. Can anyone tell me what is the network ID of this IP address?
127.
Network ID.
126.
10.000.
10.0.
If you are saying 10.10.10.10 is the valid IP address. If you are saying 10.0.0.0,
And it's a 10.10.10.
10.10.10.10,
0. Last
0.
bit is 0. This is a IP address. I
This
mean
is
a
the
network
network
ID,
ID.
network ID, network ID.
So how you calculate, brother, this network ID?
By looking at the subnet mask.
10.0.
Yes. The actual way is if you are learning it first time, so you should convert both things in binary. So if you will convert your IP address in binary, so binary of 10 is 00001010. Then dot again binary of 10 00001010. This is binary of 10 again binary of 10 again binary of 10. There are 4 field in all field value is 10. So 00001010. 1010 is the binary of 10. Okay, after that you will convert your subnet mask in binary. So subnet mask of first octet is all bits is 1 1 1 1 1 1 1 1 1. After that in second octet also you can see 255. The means all bits is 1 1 2 3 4 5 6 7 8. After that again 1 2 3 4 5 7 6 8. This is first 24 bits, that is 1. After that last one is 0 0 8. 8 times 0. Yes or no? You will convert both into binary. After that you will perform what? AND operation over here. AND operation. You all know AND operation.
Yes, sir.
In AND operation, if input is 0 0, then output is what? 0.
Zero.
If input is 1 0, then output is what? 0 or 1?
Zero.
0. When input is 1 and 1,
One.
then output is 1, and when input is 0 1, then also output is 0. This is nothing but the AND operation. So it is going to perform AND operation here. After AND operation, see, after AND operation, 0 and 1 will become what? Here you can see value is 0 and 1. 0 1 will become 0 0 0 0. After that 1 1, this bit 1 1 1 1 will become 1. After that again 0 1 will become 0 1 0. Dot 0 0 0 0. After that 1 1 1. फिर again 0 1, that will be 0. फिर 1 1 1. again 1 1, so it will be 1, and again 0 1 will be 0. Dot 0 0 0 0 0 1 0 1 0. This will be the output, and here in the, see, the lower line all bits is 0, so all value will become what, 0 over here. Yes, now you need to convert it again into decimal, in decimal. So if you will convert in decimal, here value will be 10, in second octet value will be 10, in third octet value will be 10, in fourth octet value will be 0. So this will be the network ID of IP address. Okay, here I am writing IP address 1, and my subnet mask is 255.255.255 dot, not 255, let's say 10.0.0.0. This time tell me what will be the network ID.
10.0.0.0.
10.0.0.0. Definitely yes. 10.0.0.0. Because that time, see, in third, here last 3 octet is 000, means whatever value is there, these all value will become 0, and only in first octet all bits is 1, so same value will be copy here. Yes or no? Okay, so this is how we find network ID. Now I'm writing one IP address over here, 192.168.10.10, subnet mask 255.255.255.0. Let's say this is my network ID, network IP address, and this is my subnet mask. So network ID will be what? Network ID will be 192. See, the octet where all bits is 1, I am not touching. Same value I am copying over here, 192.168.10. But in last octet, all bits is 0. That's why I have given IP address 0. So here value will be 1. 192.168.10.0. First IP address will be 192.168.10.1. This IP address is nothing but your network ID. This is reserved for network. Network ID. This is your first valid IP address. If I will talk about the second valid IP address, that will be 192.168.10.2. What will be the last valid IP address? What will be the last IP address? 192.168.10. See, till here value will be same because these are network portion. Yes. Here value will be maximum, that is 255. In one field value can be 0 to 255. This will be the last IP address. And last IP address is your broadcast ID. Broadcast ID means last valid IP address is 192.168.10.254. This is the last valid IP address. Can anyone tell me how many valid IP addresses are there in this network?
254.
254 valid hosts are there that we can configure on PC. And let's say I need to design one network where I need only 100 IP address. So if I will use IP address from class C, that means we will waste some IP address there. I need only 100, but I am getting 254. Yes or no?
Yes, sir.
So my network size is, let's say, large over here. From class C, the size of my network is 254. From class B, it will be more. From class C, it will be more. Yes or no?
Yes, sir.
So to divide this network, large network, into a smaller part is known as,
Subnetting.
yes, is known as subnetting. And that is our next topic. Subnetting. Subnetting is a process of dividing large network into a smaller network. What we can say, subnetting is a process of dividing large network into a smaller network. Okay, before starting subnetting, let's understand classless inter-domain routing. Classless inter CID CIDR value. CIDR values is also reserved for each class. CIDR value represent the network bits. It is classless, means, you know, by default from class B we can design two network. So 2 to the power 7 network. 2 to the power 7 network. That is what? Class full. That means we can change the network portion value. It can be 0 to 255. In the first octet value can be 0 to what? Hello?
127.
127. Okay. This is classless, and classless domain. Classless means prefix length is also predefined according to subnet mask. So if we have a subnet mask of 2255.0.0.0, means how many bits, how many network bits are there? There are 8 network bits, so we can represent it by /8. In 255.255.0.0, how many network bits are there?
16 slash 16.
16. So we can say /16 over here. For the class B, class C, 255.255.255.0.
Slash 24.
Here, how many
That's
network
24.
bits? 24. Okay. Now I am writing one IP address over here, that is 192.168.10.0/24. This is by default. That means there is only one network. There is only one network, and that network will start from 192.168.10.1 and it will end on 10.255. Done? Yes or no?
Yes, sir.
Can
But
you
if
re-explain that, please? Sorry, can you re-explain that?
See, here first IP address will be brother 192.168.10.1. Yes or no?
Yes,
And
that.
last IP address will be 192.168.10.255. Yes?
Mm-hmm.
Because by default subnet mask is 255.255.255.0. CIDR value is this one, means prefix length is till here. Prefix length is till here, first 24 bits. But if I will set it not 24, 25, now what will happen? Now what will happen? Now I don't know how many network portion are there. Till here I am able to see 24 bits is network, but here value is 0. That means these 8 bit is, if you will convert last value in the binary to 92.168.10.0, 0 into binary, it will be what? 0 0 0 0 0 5 6 7 8 9 8. Done. So 24 bits and 1 bit, 25 bits. These bits are network portion. That means we can change this value. Yes or no? These are host bit. Yes or no?
Yes.
So till here now we have network bits. So this value is 0. If this value is 0, then network ID is what? 10.0. If this value will be 1, if this value will be 1, then what value you will get over here? 128. Yes or no?
Yes.
Means that is your second network. Yes or no?
Yes, sir. Yes, sir.
Or there is one formula. 2, 4, 6, 7. One more zero should be there. This one. There is a formula to find the number of network. Number of network equals 2 power n, where n is what?
Number of bits.
Borrow bits.
Borrow bits.
Borrow bits means
Borrow from host portion.
yes, borrow from host portion. Like here for class C by default CIDR value is 25, but we are using /25. That means we have borrow 1 bits. 2 to the power n. This is n. And n is the borrow bits. Or we can say n is the bits which shifted in host portion from the network portion. Which shifted to host portion. After that, there is one second formula to find the block size, and block size tells us the second network. Like here, as I told you, that if this value will be 0, then network ID will be 10.0. If this value will be 1, then network bit will be 128. And these are host portion. Yes or no?
Yes, sir.
Like that also you can calculate, or you can calculate with block size. Your next network will start from here. So block size formula is 256 minus subnet mask of last octet. Getting my point? Subnet mask of last octet means subnet mask of that octet where last one is present. After that, there is one more formula to find valid host. And formula to calculate valid host is 2 power h minus 2, where h is
Host bits.
Host
number
bits.
of host bits. Done. These are 3 formula for the subnetting. Okay. So I am writing this IP address again, 192.168.10.0/25. 25. That means I have borrow how many bits?
1 bit.
1 bit. So number of network will be what?
2 to the power
To the power 7.
2 to the power 7 or 2 to the power n, where n is borrow bit.
1,
So 2 power
1,
1. Very
One.
good.
1.
And 2 to the power 1 is 2.
2.
So number of network will be 2.
2.
Block size will be what?
Block size will be
256.
minus 128.
Yes, 128. Because here if you will convert 255 into binary /25 into binary, so there will be all binary in first octet, there will be all binary, all 1 in second octet, there will be all 1 in third octet also, but in fourth octet there will be 1 1, and all 7 bits will be what? 0. 1 2 3 4 5 6 7, and the decimal value of this is 255. So subnet mask, my new subnet mask will be this one. Whenever I am using /25, then my subnet mask will be 255.255.128. So last octet subnet mask is 128. So block size will be 256 minus 192. That will be 128. Sorry, 256 minus 128. That will become 128. After that, valid host. So varied host will become what? 2 power h. See, if we have 25 network bits, means how many host bits we have?
Uh,
Total size of IP address is 32 bits. Out of 32
7.
bits, 20.
7.
Yes.
one valid host has 126
128 minus
to
2, that will
126.
be 126. Yes, any was speaking something? Hello. Okay, guys, is it clear to everyone?
Yes, sir.
Yes, sir.
What about others? Abhishek,
Got it, sir.
Abhishek, am I audible? Yes, Adil. Yes, Nirav.
Sir, can we use the CIDR of 23 for this particular example also?
Yes. You are saying to use 23 over here.
Yes, yes.
Not possible. You are using IP address from class C, na?
But sir,
Here
then,
already 24 bits is reserved for network, right? That we cannot change, brother. We
but
cannot
sir,
use 23. If we will use 23, then what will happen? See. Now network bits is
23 network bits.
so subnet mask will be what? 255 dot
55.
255 dot
More than 256.
250 2 254 dot 0. This will be the subnet mask. Yes or no?
Yes.
Now it means how many network bits we have? 1 1 1 1 means 8 bit plus 8 bit plus 8 bit and plus we have, sorry, not 8, 8 plus here we have set 7 bits. This means if you will convert this binary, this 10 into binary, so binary of 10 will be what? Binary of 10 will be 0 0 0 0 1 0 1 0. So we have reserve bit till here only. Yes or no?
Yes.
If I am using slash 23, but we have how many reserve bits for class C?
Bits.
24 bits. So we are going below, brother.
But sir, then CIDR will basically mean classless. That's why.
But we cannot use slash less than slash 24 for class C, less than 16 for class B.
We can't go below than default value, I think.
Yes. So it is slash 25. Yes, Adil, is it clear to you? Guys, this is first day. We are not going to discuss anything else today. Just revise these things tomorrow. Tomorrow we will start submitting and we will try to finish submitting and VLSM as well. After submitting, we need to discuss VLSM and FLSM. Yes, fam.
Yes, sir.
Yes, tell me. You are raising hand.
Hello,
No,
sir.
I have not
Can you
raised
tell
hand.
me the block size?
Block size?
Yes, sir.
Block size formula is 256 minus subnet mask of last octet. Here, say, let's say I am writing one subnet mask 255, 255, 255.128. Means last one is present in which octet? Fourth octet.
Yes.
And this is the subnet mask of fourth octet. So we need to subtract this value 128 from 256. You will get block size.
Last digit we have to subtract from 256.
256. Here is the formula 256 minus subnet mask of last octet. You can take one screenshot of it. Tomorrow we are going to use only this formula. These three formula. Okay. You all have received material, study materials.
Yes, sir.
No.
If anyone have not received, you have not received. Okay, I will send you again.
For me also not
Please
received.
share your mail ID.
Okay, sir, I will.
Yeah, I'll share you on the in chat.
Yeah, send me. I am sending you. If anyone have not received the study material, please share your
So
mail
yesterday
ID.
you have sent, no?
Yeah, yesterday I have sent to you.
Sir, in shared drive, actually, I am able to see this ASA image only.
Oh, really?
Yes, yes.
Okay, I will check it again.
Sir, can I get this recording video of this?
Yeah, I am sending you recording